Hello! I'll try to explain what are artificial intelligence and neural networks and how it works in 10 minutes. Artificial intelligence, or AI, is a technique which enables machines to demonstrate human behavior. Machine learning is a subset of AI which uses statistical methods to enable machines to improve with experience. Deep learning is a subset of machine learning which uses artificial neural networks. Recently, however, it's believed that artificial intelligence is a software or hardware-software complex that basically uses artificial neural networks. So what are artificial neural networks? Artificial neural networks are a simulation of biological neural networks. This simulation is very rough, though this simulated neural network is capable to solve new human problems. This figure shows the simplest neural network. The network consists of layers of neurons. Each neuron has many inputs from the previous layer. The input of the first layer is the input data, and the output layer is the desired decision of task. Thus, the network learns to approximate a function of many variables. The artificial neuron itself performs the function of weighted summation of its inputs, and then performs some function of nonlinearity. For example, sigmoid function or ReLU function. So, artificial neuron is quite simple item. There are three fundamentally different approaches to learning neural networks. First is supervised learning. This is when there is a training sample consisting of inputs and desired outputs. For example, if you want to create a network that learns to distinguish cats from dogs, so a training sample will consist of photos of cats with the label that it's a cat and photos of dogs with the label that it's a dog. You should have a lot of data, a lot of such examples to learn the network. In this case, you act as a teacher. Unsupervised learning. This form of learning is rarely used in pure form. This task is essentially a clustering task. There is only input data. The network learns to divide the input data into a certain number of types, and you should be able to use information received by a network. Reinforcement learning. This is the most interesting form of learning. In this case, a network is an agent in some environment and operates in this environment. For instance, in a computer game or in the real world. In this case, a teacher is the environment itself. The environment gives a response in form of states and rewards for actions of a network. Reward can be positive or negative. The network receives observation of the environment and learns to give output leading to the maximum reward. By the way, learning algorithms for artificial neural networks have nothing to do with learning algorithms of biological neural networks. We don't know how biological neurons are trained. Perhaps, by the way, this will be the key in the future, I think. People who are engaged in creation of neural network models and their training is now called data scientists, and field of knowledge is called data science. Now invented a huge number of network types by its architecture, and there are four main of them. First is fully connected neural network, which also called multi-layer perceptron. Each neuron of the next layer is connected with all neurons of the previous layer, therefore it's called fully connected. The input of the first layer is the input data. Output layer is the desired decision, and in this case this is belonging to one of the classes. And inside are hidden layers. This architecture is universal and can be applied to any task, but it has redundancy of neural connections, and it's not always possible to train big networks with many hidden layers. Second architecture is convolutional neural network. These networks are usually used for images processing or image sequences processing. The architecture uses some features of a visual cortex. These networks are based on a convolution operation. Each neuron of the next layer performs convolution with the output of the previous layer, with a certain window size and depth of previous layer. The depth of the current layer is defined by the number of such simple networks, which also called filters. Last layers can be usual fully connected layers. There is an example of convolutional network result. In this slide you can see results of recognition and object detection task. Neural network can recognize cars and persons and confound positions. Variational autoencoders. Variational autoencoders is based on the previous architecture. The left part is convolutional neural network and is named encoder. The right part is deconvolutional neural network and is named decoder. The middle is the compressed internal representation of the data. Neural network learns to code and decode information. You can teach a variation autoencoder just by applying the same image to input and output. In this case, the network learns to compress information, and then it's possible to use encoder or decoder separately. You can also teach variation autoencoder by applying the image to input and the segmented image to output. In this case, the network learns to perform segmentation task. These are results of segmentation task. The first row is the input images of street roads. The second row is the result of segmentation. As you see, network capable to split road surface, cars, trees, buildings and humans. The third row is the input images of interiors. In the fourth row, network recognizes floor, chairs, couch and so on. Next type of architecture is recurrent neural network. Recurrent neural networks are used to work with sequences. For instance, in problems of machine translation, speech recognition, text generation, etc. They are called recurrent because the output of a network is fed back to its input. In this picture, green box F is the same neural network, and word sequence is fed to the network input. The output is other sequence which can be translation to other language or, for instance, some summary of the input text. This makes it possible for a network to memorize the sequence fed to it and generate output data, which based not only on the current data block, but on the entire sequence. This approach is used in voice assistants, language translation services, text generation and music generation, for instance. The last architecture for today is Generative Adversarial Networks, or GANs. These networks are used to generate images or videos similar to real ones, or to generate any other data that is undistinguishable from a given dataset. GAN is neural net architecture comprised of two nets, complete one against the other, thus the adversarial. Here are the steps a GAN takes. The generator takes in random numbers and returns an image. This generated image is fed into the discriminator alongside a stream of images taken from the actual ground truth dataset. The discriminator takes in both real and fake images and returns probabilities, a number between 0 and 1, with 1 representing a prediction of real image and 0 representing fake. The generator learns to generate such images that the discriminator cannot distinguish from the real ones, and the discriminator learns to distinguish the generated images from the real ones. Here are some results of state-of-the-art GANs. All of these people are generated by GAN. They are not existing in fact. As you see, it's quite realistic. And this picture shows room interiors generated by GAN. And this picture shows photos of cats generated by GAN. As we see, it seems real in most cases, but in some cases it's clear that this is fake. The success of neural networks is directly related to the explosive growth of computing abilities, and particularly explosive GPU power growth. GPU means graphical process unit, which usually used for graphic acceleration in computer games. Now usually neural nets are trained using GPU. So, What is artificial intelligence? Modern practice is this. AI is a software package that solves human tasks and clones human behavior and is based on neural networks and uses hardware acceleration with GPU. And it can consist of many subsystems. Each subsystem can be one or more neural networks which can be trained in different ways. Conventionally, AI is divided into weak and strong AI. Weak AI is an intelligence that solves the narrow human tasks. For example, face recognition systems, self-driving cars, voice assistants, and in general any system which is created for today. This AI system is created for narrow human tasks and can be compared with the human mind. Strong AI, as scientists hope, is an intellect capable of learning all tasks of humans, capable to understand the world, which have its own goals, which can easily interact with our society. And while such intelligence hasn't yet been created, of course. So, can AI outperform humans? In some tasks, yes, I think it's possible. Strong AI replaces humans in most professions. I think somewhere in 15 years there will be created humanoid robots with a strong intellect, capable of learning most tasks inherent in man. There are no contraindications for this. And should we be afraid of AI? No, of course, but we should be ready to appearance of such AI. It's necessary to understand that AI doesn't exist without people who serves. AI cannot develop, cannot have goals without human presence. It's like a computer. Does it make sense a computer without user? It was George, and I hope it was interesting. Bye.